breakthroughs in science and technology, innovations in business and beyond. Join us as we educate, enlighten, and entertain. This is Advancements.
Hi, I'm Ted Danson, and this is Advancements, an educational series dedicated to informing the public on the latest accomplishments unfolding across the globe. Throughout this series, we'll explore the significant issues impacting our lives today and discover how we're preparing for the future.
Living things comprise a typical hierarchical and porous medium, with their most fundamental logical architectures being interstitial structures.
We generally think of bodies as made of cells, and in many places the cells are right up against each other. But for lots of places in the body, the cells aren't up against each other, and those can't be empty spaces. They have to be filled with fluid. That's the interstitial fluid. It's what fills the spaces between cells. The work we did by looking at tissues with a microscope is that those layers of collagen are actually open fluid-filled spaces, and that's a third much larger compartment of interstitial fluid. The smaller spaces feed into this larger space, and that forms a network throughout the body. Wherever you have collagen, wherever you have connective tissue, there's all sorts of molecules passing through it. Sometimes cells are passing through it, but not as often. Cancer. We know that it spreads through blood vessels, through lymphatics, but it also turns out it spreads through the interstitial spaces, through the interstitial fluid. So it's very important for disease. Infections. There are many infections that spread through the interstitial network.
As a fundamental, yet often forgotten part of anatomy, interstitial fluid plays a major role in delivering key nutrients and expelling cellular waste to and from the cells via the circulatory system.
What's new about our understanding of the interstitium is that it is a body-wide system that links up across all organ boundaries. It used to be thought of as just spaces between cells or spaces around the smallest blood vessels, around the capillaries. That's where nutrient and waste exchange happens in the body. And it turns out that those spaces throughout the body are 4 times the size of the cardiovascular system. Our most recent research in living tissues shows these spaces in between are filled with hyaluronic acid, which is sort of a filtering molecule, and fluid is flowing through those. So it's a major highway of communication through the body.
However, gaining access to this vital part of our anatomy has been incredibly complex and challenging.
There have been 2 reasons why it's been difficult to access the space where you get interstitial fluid. One is, until recently, we didn't understand the structure. We were focused on these tiny spaces between cells or around the capillaries. We've been walking down sidewalks, and it turns out there's a superhighway we were ignoring. The second thing is that superhighway is actually filled with hyaluronic acid, which is sort of like Jell-O. Separating those 2 out is the tricky part.
A really good example of how interstitial fluid can provide access to earlier outcomes is in prostate-specific antigen. So it's a really commonly used biomarker for prostate cancer. And we can continuously sample interstitial fluid at home using a KIFFIK device. We can measure the PSA on the device, and that can give patients an early indication that they may either have prostate cancer or that it's come back. That will allow patients to get much more access to care quicker, easier, and allow them to get their PSA level at home in a format they're comfortable with.
Now, for the first time, extraction of bio-rich interstitial fluid with all of its components will be available for multiple health scenarios.
Polytrauma patients are patients who sustain multiple injuries. They might have broken bones, they might have injuries to their chest where there's broken ribs or their lungs are punctured. We use biomarkers to try to determine how they're going to do after an injury. 2 people might be hurt the same, they look the same, but one does very well in the next couple days after injury and the other one gets very sick and sometimes die. And the differences that we have seen in patients very likely track back to substantial individual differences in how their immune system produces the inflammatory biomarkers. What interstitial fluid does is it opens up our ability likely to do real-time testing, which has high potential to change the way we understand and potentially treat polytraumatized patients.
KIFFIK's wearable, connected device allows completely non-invasive access to interstitial fluid and is capable of transmitting health data from nearly anywhere in the world.
I believe access to biomarker-rich interstitial fluid will revolutionize the care of veterinary species and improve animal health. Dogs and cats, they can't tell us what's wrong. Sometimes they have difficulty communicating with us, and they can't always participate in their own care. So by having access to the interstitial space, I can understand better what's happening with that animal physiologically and emotionally, as well as deliver the best, most precise and personalized care.
If we were able to measure biological target engagement directly in the fluid around the cells, we would boost the pace of discovery.
The world of interstitial fluid opens a greater understanding of how humans can reach better health through continuous monitoring and better diagnostics, and will expand possibilities in preventive medicine, accelerate the discovery and development of new therapeutics, and empower patients to proactively manage their health.
We know our body has a biological clock. Some cells sleep, some cells are awake at different times. This technology will allow us to be able to monitor things in real time and see where there's a fluctuation in levels of biomarkers, for example, which are indicative of disease.
One of the easiest examples is blood glucose, which we can measure already using older types of technology, but it can't be measured accurately continuously. The KIFFIK technology will allow us to sample blood glucose across a range of time points, even continuously, and allow us to understand whether somebody's glucose tolerance is impaired. And that's really important because it allows us to diagnose diabetes earlier and do something about it.
Since we've only really just begun understanding how to isolate interstitial fluid and how vast the network is through the body, but what we now understand is that by accessing that fluid, we're accessing something that reflects the body as a whole.
Thanks for joining us today. We hope you'll tune in next time as we continue to explore some of the significant developments impacting the world around us. I'm Ted Danson.